In this video, let us see interpolation for equal intervals. So here we are going to see Newton's forward interpolation formula and Newton's backward interpolation formula. For that, first let us consider the following data. That is, let us consider the x values as x0, x1, x2, etc., xn, and y values as y0, y1, y2, etc., yn. If these are the given data, for this data, what is the formula for Newton forward interpolation formula and what is for Newton backward interpolation formula? So now before moving to the formula, first let us see what do you mean by forward difference table. So first we have to write the values of x and y in a vertical way. You have to form a table like this. So first here this symbol delta y represents the first forward difference, that is nothing but the difference between y1 and y0, that is y1 minus y0. Always you have to subtract first value from the second value, right? Similarly here from between y2 and y1 we have to subtract y1 from y2, that is y2 minus y1. Similarly here y3 minus y2 and y4 minus y3. So these difference are represented as delta y0, delta y1, delta y2 and delta y3. Similarly for a second order difference, it is denoted as delta square y. The difference is we have to take the difference between the first order difference, that is delta y1 minus delta y0. Okay, so that is denoted as delta square y0. Similarly, delta y2 minus delta y1 is nothing but delta square y1. And delta y3 minus delta y2 is nothing but delta square y2. So these are called as second order forward difference. Similarly, third order forward difference is again difference between these two consecutive values. Always you have to subtract first value from the second, that is second minus the first value. So that is represented by the symbols according to the order of difference. Okay, this is first difference, second difference, third difference, and fourth difference. It goes on like this. Actually always we have to extend the formula till we end up with a single value, right? So if you include one more column for delta power 4, subtraction of delta cube y1 minus delta cube y0 will be delta power 4 y0, so that we will end with a single value, so there we can stop the calculation, right? Otherwise, depending upon the number of value, we have to extend the difference table. So corresponding to this difference table, we are having the Newton forward interpolation formula. The formula is y of x is equal to y0 plus u into delta y0 plus u into u minus 1 by 2 factorial into delta square y0. It goes on like this, where here this u stands for x minus x0 by h. Actually here h is the interval length. Interval length means how to calculate this h interval length is the difference between the values of x. Since we are dealing about equal intervals, the difference between x0, x1, x1, x2, x2, x3, x3, x4, everything will be the same. Okay, so h will be having the same value, that is common difference, that is common difference of x. So that will be taken from the question, and x0 is the very first value of the given data, and x means that is the value for which we have to calculate the value of y, that will be asked in the question itself. So now we have to remember the Newton forward interpolation formula like this, and if you notice this delta y0, delta square y0, delta cube y0, delta power 4 y0, etc. will be taken from the table. That is, this is delta y0, delta square y0, delta cube y0, that is all the first value in the table should be considered as the difference value, that is delta y0, delta square y0, delta cube y0 and so on, right? Similarly, if we see backward difference table, difference is the same, that is we are taking the difference y1 minus y0, y2 minus y0, here also second value minus the first value, but the notation what we are doing here is del symbol. Okay, that is inverted delta, and then here if you notice this should be denoted as del y1. In the previous case forward difference it is delta y0, here it is del y1. So according to that we have to find out the difference table. Okay, so actually if you see difference table is the same, okay, but the notation is different. Okay, so while doing the problem we have to consider a common difference table. It's enough for both forward as well as backward. Okay, for forward we have to take all the first value of each column, and for backward formula we have to use all the last value of each column. That is, if you see the formula for Newton backward interpolation, it is denoted as y of x is equal to yn plus v into del yn. Again here v into v plus 1 by 2 factor into del square yn. It goes on like this. See here, del cube yn, del power 4 yn, it goes on like this, where v is equal to x minus xn by h. Here again h is the equal interval length, and xn is the last value of the data of x, and x will be given in the question itself, right? And then if you see, delta yn is nothing but the last value of the difference table. See here we are ending with the last data as y3. So here if you notice, the last value is del y3, del square y3, del cube y3. If you notice in the forward difference table, all the top values will be delta y0, delta square y0 and delta cube y0. So here it's enough to have a common difference table for both forward formula as well as backward formula. Here let us see one problem under Newton's forward and backward interpolation. So first question is, find the values of y at x equal to 21 and x equal to 28 from the given data. So the data is given as x is equal to 20, 23, 26, 29, and corresponding y values are given here. So here if you notice the values of x, they are equally spaced. So that is, difference between 20 and 23 is 3. 23 and 26 is 3, 26 and 29 is 3. So we can consider this problem is under equal intervals. So equal intervals means we are having only one method, that is called as Newton's forward interpolation and Newton's backward interpolation. Why we are calling forward and backward? Why two different formulas? See, if you want to find a y value at x equal to 21, 21 is towards the beginning of the table, that is between 20 and 23. Similarly, if you want to find out for x equal to 28, 28 towards the end of the table, that is between 26 and 29. So that for 21 we have to use forward difference formula. That is, when x is equal to 21, we have to use forward difference formula, and similarly x is equal to 28, we have to use Newton. Okay, Newton backward difference formula, right? Why we are using forward difference means beginning of the table, right? And backward is for towards the end of the table. Okay, so like this we have to find out. Please don't use the same formula for both. Actually, if you use same formula also, will be getting the answer, but the purpose of forward is we have to apply forward only to find the beginning of the table, and for backward it is used to calculate the value towards the end of the table. Okay, before going to the formula, first let us form the difference table here. Okay, so difference table is, first we have to write the x and y value in a table format by considering the values in the vertical manner. Okay, so take the given values from the question, x values and y values, right? Now how to find out the difference? First order difference delta, how to find out is, always I told you that second value minus the first value. That is here 0.3907 minus 0.3420 will give you 0.0487. Similarly here 0.4384 minus 0.3907 will give you 0.0477, right? So likewise we have to calculate. That is here 0.3907 minus 0.3420 will give you 0.0487, right? So this is what this value. Similarly 0.4384 minus 0.3907 is equal to 0.0477. Similarly 0.4848 minus 0.4384 is equal to 0.0464. So these are the values called the first difference delta y. So that should be placed over here. While writing the value, please write in a triangular manner. That is, in between this value you have to write it. Again, if you move to the second order difference, again you take difference between these two. That is 0477 minus 0.0487 will give you minus 0.0010, because this is the least value compared to this one, right? 77 minus 87 means it will be minus 10. So minus 0.0010. Similarly here 0.0464 minus 0.0477 will give you minus 0.0013. Again minus 0.0013 minus of this will become plus. Anyway, we have to subtract it, right? One is both are negative, so we have to subtract it. Let me write it over here. We have to do like this. This is the actual calculation. So minus into minus will become plus. Again you have to subtract it. So the answer will be minus 0.003, because please do these calculation using calculator, okay, so that you can't able to do any mistakes, right? So that like this, now this value is nothing but delta cube y, okay. So already delta square y is in the table itself. So here we can't able to proceed further, so always you have to stop the table till the single value we are having, okay. So further delta power 4 we can't able to calculate, because to calculate the difference we need minimum 2 values, then only we can find the difference, okay. So successively if you find the difference like this, at one point we will end with the single value, so there we can stop the difference table. So how long it goes, till that we have to do the difference table. Now if you notice, all the top values I told you that it is delta y naught, delta square y naught, everything. Similarly all the last values I told you that it is denoted as yn. So all the first value should be taken for the forward difference formula, and all the last value should be taken for the backward difference formula, right? So this is actually x naught, this is y naught, and this is delta y naught, this is delta square y naught, and this is delta cube y naught. So these are the values we will be using to put it in the formula, Newton's forward interpolation formula. Similarly, this is xn, this is yn, and this is del yn, this is del square yn, and this is del cube yn. So all the last values are represented in terms of yn, okay. So we have to substitute in the respective formula to find the value. Now this is the Newton forward interpolation formula. So here we have to calculate first u. So u is equal to x is, this is used to calculate for x is equal to 21. What is the value of y? Okay. So here x takes the value 21, minus x naught is the very first value given in the table, that is 20, divided by h is what? Common difference, that is 3. So 21 minus 20 by 3 is 1 by 3. Okay. So we can substitute, either we can substitute 1 by 3 or we can substitute 0.3333. So always place it to 4 decimal place. Okay. Now we are finding y of 21, which is equal to y naught, we have to take it from the table, that is 0.3420, plus u is what? Here let me write it as 1 by 3. 1 by 3 minus 1 divided by 2 factorial is 2. So before that I left this one term, u into delta y naught. So before this I have to write, so u is 1 by 3 into delta y naught. Delta y naught is the first value of the first order difference, that is 0.0487, right? Plus 1 by 3, 1 by 3 minus 1 divided by 2 factorial is 2 into delta square y naught is, take the first value from the second difference, that is minus 0.0010, again plus 1 by 3, 1 by 3 minus 1, 1 by 3 minus 2 divided by 3 factorial is nothing but 6 into delta cube y is minus 0.0003. So if you notice the table, in that table we are having the last difference as delta cube y naught, so no need to proceed further. So we can stop the formula till delta cube itself. Okay. So now if we calculate, we'll be getting the answer as 0.35 0.83, and this is the value of y of 21. Similarly, we have to do it for backward difference interpolation. So now coming to backward interpolation formula, this is the formula. Now here we have to calculate V. So backward difference formula we are using to find for x is equal to 28. Am I right? So x is equal to 28 minus what is the last value of the table? 29 divided by h is the same 3. So here it is minus 1 by 3. Whereas in forward formula u is equal to plus 1 by 3. Here v is equal to minus 1 by 3. That is we have to calculate y of 28 by substituting all the respective values here till delta del cube yn. That is yn is the last value of y naught plus v is minus 1 by 3 into del yn is last value of the first difference table. Next minus 1 by 3 minus 1 by 3 plus 1 divided by 2 factorial into del square yn is minus 0.0013, again plus 1 by 3 minus 1 by 3 plus 1 minus 1 by 3 plus 2 divided by 6 factorial, that is 3 factorial is nothing but 6. Here also 2 factorial is 2, right, into del cube yn, that is minus 0.0003. That's it. So here this gives you the value after calculation 0.4695. So this is the answer for y of 28, right? So this is the way we have to apply Newton forward and backward interpolation formula.